Is to answer some of the questions I've been getting emailed from you about how we can move objects around. So what I'm going to use in this demo is the built-in NGL diffuse shader, but it's pretty much the same for all shaders in OpenGL. And the core part of the shader, if we ignore all of the lighting elements here, is this setting of GL position. That sets the final position of the vertices that we wish to pass to OpenGL to be displayed. And each one of these vertices is multiplied by this 4x4 matrix MVP. This is our modeling, viewing and projection matrix, and we multiply each of the vertices for the model by this matrix to give us our final transformed point. Now, whilst this is a single 4x4 matrix, it's actually the combination of three matrices. M stands for modeling. That's the actual movement of the object that we want to set. V stands for view, and that's actually our camera. And then finally, P stands for project, which is the projection into either orthographic or 3D volume of our points. And every time we want to set our vertices, we need to, in our program, calculate this model view project matrix, pass it into the shader, and then multiply all of the positions by it. Now, for most demos, view and project are not going to change for each of the models that we're generating. So we can calculate this once, and it's just the M that will need to be changed per model to move it around in 3D space. So let's have a quick look at how we can set up our initial view and project elements, and then we'll move on to moving objects around. So in this very simple case, I'm using the NGL lookat function to generate the viewing matrix. Now, we've covered this in the lectures, so if you need refreshing on how this works, have a look at the lecture notes. But basically what we're doing is, in this case, generating a simple camera where we're viewing from. I'm saying 2, 2, 2, viewing 2, 0, 0, 0, and Y is upwards. And we pass this to the lookat function. It returns this matrix called view. Next, I'm going to calculate my matrix called projection. And projection, again, is being calculated by one of the built-in NGL functions called perspective. That's passing in 45 degrees field of view for our view volume, width and height, and a near and far clipping plane. And again, that only needs to be calculated based on the size of the window. Both of these are calculated once, and they're going to be used by multiplying them together and passing them to our shader. And that's what happens in this element here. We have our MVP matrix that we're going to generate here, and we're going to do that by calculating M, which is our modeling transform, which I grab from my transform stack. Just get the matrix. I'm then calculating model view by multiplying our matrix from the transform stack with the view matrix, and then finally I'm calculating model view project by multiplying the three of them together. And you can see that that's being passed to my shader here, the currently active diffuse shader. We just pass the MVP that we've got there, and what this will do, if we run the program, is at the moment I'm doing no modeling at all. All I'm doing is projection, and we should get our very simple cube there, and that's it. If I go through and change the lookat, so for example, let's look at this just from a distance of, say, 10 in Z, we should see the cube straight on. And we run it, and there you see we're looking at the cube in the Z-axis. And if we were to change the projection, we could, for example, change the field of view. If I change that to, say, 85, and we run again, we should get our field of view changed. And there it is. And if I make it closer, say 25, we'll most probably completely fill the screen with the cube because we've got wider angle for our projection. And again, There it is. No, not quite. So at the moment, that's just viewing and projection. We are not moving the object. In the next video, we'll look at how we can start adding transformations to the object.